combinations, so it changes a little bit, okay? A pizza place is offering 6 meat toppings, 8 veggies, cheese, sauce, crust, right? So you've got 1, 2, 3, 4, 5 different events, right? If you make the pizza, right, you know that it's what it's all about, right? First you need to make the dough and then put on your sauce and then cheese, right? So every station is kind of like an event. How many different pizzas could be made if you have 1 topping, 1 cheese, 1 sauce, and crust selected, right? So it's 1, 2, 3, 4. Yeah, so you have to pick 1 topping for sure. It doesn't say whether it needs to be meat or vegetables. So it's kind of like, how many toppings do we have altogether? 14. So now maybe that threw you off a little bit, right? So 1 topping, you have to pick 1 from the cheese, 1 sauce, and 1 crust. Okay, so technically there are 4 events. I'm sorry to tell you that that's what it is. So 14, you've got 14 different toppings. You've got 4 cheese, 2 sauce, and 3 crust. So that is what's happening. I think this is probably what threw you off, right? If this question had said you have to pick 1 meat and 1 veggie and 1 so forth, then there'd be 5 slots to fill in. So you have to be careful. That would be 336 pizzas. So 1 mark for that. If you split it up into 6 times 8, you went 6 times 8 times 4 times 2 times 3, I would say half a mark because you're still understanding that you need to multiply. So for today, just give yourselves half if you've done that. And I'm going to take this opportunity to have variations of this. Okay, just listen carefully. What if this question had said, how many different pizzas can you make if you go with or without sauce? With or without sauce. When it says or, right, basically what they're saying is you're going to have 1 case where you go through all of this and you include the sauces. Then you're going to go or, that's plus, right? Or you go through this whole thing, but you're not going to have the sauce in the mix. So it's basically just 3 events, right? So you need to add those 2 together when you have the or. Like one year an exam had, how many different outfits can this team select with or without socks? So you have to do the whole thing with socks, or you add all the options without socks, right? Without. So you have to add. When it says that, be careful. That is, and usually the marks are what we look for. If it's a 2-mark question, you're probably thinking of there's more than just 1 step. Okay, that's another thing. I would always look at the marks to guide me further. Manitoba license plates starts a certain series starts with JX and then has 1 more letter and 3 digits. Digits would be 0 to 9, right? That's our assumption, so 10 options. How many license plates are there in the series? So you've got J and X technically, right? So just 1 and 1, there's no option. Then you've got a letter, so you've got 26 options, and then 3 digits, so that's 10 times 10 times 10. So that would be 26,000 plates. The reason, right, like it doesn't tell us whether or not we are able to repeat, so we're assuming you can, okay? We're assuming we can have repeat letters. So you could have a 0, 0, or you could have a 0, 0, 0, like it's fine, having some repeated letters. How many license plates in this series do not have repeated digits? So it's just talking about the digits not being able to repeat. So it's 1, 1, okay? 26, because letters, we're not talking about letters not repeating, and then it'd be 10, 9, 8. So that is where the 1 mark is found in the you dropping the numbers towards the end, okay? So that would be 18,720 plates. And I have to say, this whole time, permutation notation is also allowed. So if you chose to go 1 times 1 times 26, pick 1, that would be this one, times 10, pick 3, okay? That you're gonna get the exact same answer. Because remember, 10 pick 3 means 10, 9, 8, okay? So that is still very much an option for you. So if my key all of a sudden goes permutation, you should be able to translate the permutation into blanks being filled in. Permutation, remember, when you're not allowed to repeat, you can use permutation. Permutation would have not been okay up here, okay, because you're using 10 times 10 times 10. So you don't want factorials, you don't want, this would be what? If we translated this, it would be 26 times 10 to the power of 3, right? If you wanted to translate that in terms of your work. But unless told otherwise, folks, we want the final answer. Sometimes, I know an exam one year had a factorial question which would have been too big, like the calculator would not have been able to solve it. So they did say, do not solve, just show us what the numbers would have been like how would you have written this, right? How would you have filled in the blanks, perhaps, or something like that. But most, 99% of the time, we do want the final answer. Next, how many license plates in this series have repeated digits? I'm going to translate this for you, okay? At least one repeat. That's what that is saying. Have repeated means at least one repeat, right? One repeat or 2 repeats or more. That's what that is saying. So I was hoping you were going to use your answers from the previous 2, okay? So I will just go total or universal minus no repeats. Total is 26,000 plates minus, we're going to take away all the plates that do not have any repeated digits. And when you subtract that, you get 7,280 plates. I won't say always, but quite often, if I do this to you or the province, they will set it up in this way. They will get you to figure out how many are there in total. They'll get you to figure out something like what is there, how many ways can you have no repeats? And then they might ask you, well, now that we know these 2 things, right, how many will have repeats? Go indirect reasoning. It's much easier. To find all possible ways to repeat is very difficult. You gotta talk about a lot of specific instances. Next, simplify by hand. So I need to show algebraic work to a certain degree, or arithmetic. It's not algebraic because you're not solving for x. 12p3. So basically you would just use the formula, right? Because 12 factorial over 12 minus 3 factorial. Sorry, that's what you would do there. Let's redo that one. It looks terrible. Minus 3 factorial, right? So that ends up being 12 factorial over 9 factorial. And I don't know if you remember, I break down the larger number. Okay, I will go 12 times 11 times 10 times 9, and then I stop because I see a 9 factorial in the denominator. So you cancel that out. So you get 500, no, sorry, wrong line here, 1320 is what I was looking for. But to get the number, to get the mark, you need to show me this, okay, to get the number. Okay, so keep that in mind. Next, Mr. Erickson, I want to pick a group of math for a math presentation to be at a school assembly. There are 9 teachers, including themselves, that could present. The first, how could you get the first, second, and third presenters to be chosen? Okay, no teacher presents twice. That is big. That is mean you can't repeat. So this would simply be 9, 8, 7, all multiplied. And what is that? That is 504 ways. Or you could have gone 9, pick 3. Okay, that is also 504. Unless we tell you, you don't have to do this, you don't have to show us work how you actually found 9p3. You can just plug it into your calculator and just go for it. Okay. Next, a picture is to be taken of all 9 presenters. How many ways can they be arranged if they are sitting in a row? So that's 9, pick 9. 9, pick 9. If it's 9, pick 9, you could also just say 9 factorial, right? If it's all of them. Or if you like your slots, it's just 9, 8, 7, 6, 5, 4, 3, 2, 1. Right? And regardless of how you did it, it's 362, 880 ways. 1 mark for that. How many arrangements if Mr. Erickson and Mr. D are sitting together, so next to each other? I can't do this without the blanks, folks. Okay, I can, but it's I don't know, I feel like I'm gonna get this wrong. So at first we are assuming they're in this group that we have to fix together. So that's 2 factorial, then you zoom out and you count that small group you've created as 1. 1, 2, 3, 4, 5, 6, 7, 8 factorial. Okay? So you need to go 2 factorial times 8 factorial to get that right. And that ends up being 80,640 ways. I would say this, if you get the 2, I'll give you half a mark for sure, half out of 2. If all you did is 2 factorial, you get half. I'll give you another half for having an 8 factorial show up, and then another full mark for actually multiplying these 2 together. Two teachers in the group do not get along. How many arrangements are possible if they are not to be sitting together? I want you to piggyback off of the one you just did. Okay? How many ways are there in total just to arrange them for the picture? It'd be 9 pick 9, right? Or 9 factorial. And I'm going to take away, I'm going to use this example because this is 2 people being together. I'm going to take that away from the total. Because I'm going to take away these 2 sitting together. So that's 362,880 minus 80,640. So this is all the ways where they're not sitting together. Because we already figured out the numbers before, this is only a 1 mark answer. Because you can take from the previous answers. If you had to do all this work yourself, this would have been a 2 mark question. Got it, folks? If it's a 2 mark question, you would have had to figure out this. You would have had to figure out the 2 sitting together and then subtract to get the 2 marks. So let's do the total for this page. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this page is worth 10 marks if you want to do a little sub total there already. You go for it. Backside. How many ways can you arrange the letters in the word Monday? Are there any repeats? There are no identicals. No identical letters, so this is simply n is equal to 6, so it's just 6 factorial or 6 pick 6, and that's 720 ways. Okay. How many ways can the letters be arranged if it must start with a vowel, right? So 1, 2, 3, 4, 5, 6. Okay, this is where I'm going to suggest some of you need to do it differently than what I've been showing you because I feel like it's throwing you off. So basically, I will do a case where it starts with an O, and you can do the case where it starts with an A. Those are the only two vowels. So it's 1, 1, and then you have 5 more to fill. So this would be 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. Okay? So that's basically, this top one is 1 times 5 factorial, and the bottom one is also 5 factorial. That ends up being 2 5 factorials, yes, 2 5 factorials, but let's just do it separately. This would be 120, this would be 120. You'll still get 240 ways. And this is why it feels good, doesn't it? How have I done this in the past? I've gone O or A, so I would have started with a 2. Then a lot of students go 6 minus 2 is 4, and then they go 4, 3, 2, 1. And that is the problem. You have to watch out for that. A slot is only one at a time. So it's quicker to say O or A and just go 2 and then 5, 4, 3, 2, 1. Okay? This is the quicker way of doing it. You still get 2 times 5 factorial, which is still 240. So you decide what you want to do. Of course, this is very tedious if you had like 5 different cases, right? Then you would go 1, 2, 3, like 5 times the same thing. So you want to be careful. The only time I for sure break it down into cases is if there's another restriction that I have to meet, and you starting with a certain letter or number affects that restriction at the back. So then you have to separate the cases, okay? 1 mark, all that for just 1 mark, okay? Ariana cuts up letters in the work. Unbelievable. How many ways can they be arranged to make new words? So we've got n is equal to 12. Let's see here. I've got 3 E's. I've got 2 B's and 2 L's. Okay, so you must start with 12 factorial. That's half a mark. 3 factorial, 2 factorial, and another 2 factorial. So you got to divide out the identicals. Identicals, right? So there'll be half, 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 half. Every number that shows up is half, but you have to then get the right answer to get this right, to get the full mark. So this would be 19,958,400. I know I rushed. I should have probably done the in-between step, but so you can tell your parents, can I have 12 factorial dollars, please? Because this is like what, 479 million? Just see if they fall for it. Anyways, or just text them. Can I have $12? Exclamation mark. And then later you get them, right? How many ways can you travel from A to B? You can show your work no matter what, but this would be 4 and 4, that's 8 factorial. 4 factorial, 4 factorial. This is the easiest case you can possibly get. There are no bottlenecks, nothing like that. So this would be 40,320. 4 factorial is 24. 4 factorial is 24, so that's 576. 70 ways to get from A to B. If you prefer the counting method, go for it. It's fine. There's a case that I'm going to show you where you can only use counting. The other one doesn't work. They promised us they wouldn't show up on an exam anymore, but I feel like you never know. So I'll do it like towards just before exam prep. I'll show you that. I won't show you that now because I won't have it on a test. Okay. Next, a bag contains 4 red, 5 blue, and 6 marbles, 6 white marbles. So that's what, 15. How many ways can these be arranged in a row? They are identical. Okay, marbles, you have identical. So this is 15 factorial over every single one. Every single color represents a repeat. They're not the same. So have a mark for every single number that shows up. This is where it gets tricky. 15 factorial is not just 1.307. That's what a lot of you would love to be able to write, but it's actually times 10 to the 12. It's E12. If you look at your answer, it's a really big number. But when we write this down in the denominator, if you go 24 times 120 times 720, you get 2,073,600, right? So once you divide it, you copy this number, you divide it by that number, you get 630,630 ways. So the emphasis on marbles, emphasis on things that would look exactly the same that you could not tell apart. And in this case, I would have been like, whoa, that's a big number. Like, it can't just be 15 factorial, right? It's a little off. So maybe that should have helped you here. So we've got 2, 4, 6, and 8. 8 marks for this backside.